to start off our review, let's look at the red problem. What kind of problem is this one? Am I adding, subtracting, multiplying, or dividing? Multiplying. Now, what was the rule when I'm multiplying bases? Add the exponents, but I treat the big numbers like I've always treated big numbers. So I'm still going to multiply 5 times 3. What's 5 times 3?
15.
And then what am I going to do with the small numbers, with the exponents? Add them together. So 2 plus 7 is 9. Do y'all remember doing that last time?
Yes.
Okay, great. That's the first rule. It's called the product of powers. It's straight up on your formula chart. Go ahead. You got time. It means if we're multiplying the bases, we add the exponents, but we go ahead and multiply the big numbers because we're said to multiply them. Say that again? Okay. For the second problem, I'll go back. I'll zoom out in a second. We have a new rule. We're dividing these bases. So what do I do with the exponents? Subtract them. It's called the quotient of powers rule. It is on your formula chart. But we treat the regular numbers like we've always treated regular numbers. So we're just going to divide the 12 and the 4. What's 12 divided by 4? 3. And then we have 8x to the 8th divided by x. What's the exponent right here? 1. So there's a sneaky 1 right there that we can write in. So when I know that I'm subtracting, I'm just doing 8 minus 1, thank you. And 8 minus 1 is 7. Now what's wrong with the way I wrote the 7 right now?
It's not an exponent.
It's too big. It is not an exponent. Remember, I'm picky about that. Exponents have to be floating, so they have to actually look like, a whole exponent. Great. Those were the 2 of the first rules that we saw. Yes? Then we got to this rule. This was the last part of our acronym, and it's power to a power, because we have parentheses, so it's powers on parentheses. What do we do with those exponents? Multiply them. So it looks like distribution. It's not really distribution, but it kind of looks like it. This is going to simplify to y to what power?
12.
To the 12th power, and that's it. That's the simplified equivalent form for this expression.
What?
We have powers raised to powers, so we just multiply the little numbers together. Yes? Does that sound familiar? This is on your formula chart. It's called the power of a power rule. Okay? The last rule, it's combining 2 of them together. Let's see what you remember. What's your first instinct when you look at this problem?
Little numbers. Variables.
There are variables. There are little numbers. Specifically, what kind of little numbers right here?
0.
What's anything raised to the 0 power?
0.
1. The whole thing, this entire y to the 0, is going to change to a 1. It's basically as if it disappears. If it disappears while it's still being multiplied to something, you can basically just cross it off. But if it disappears and it's the only thing there, you have to write down a 1. So like this problem right here is now 3x to the negative 3 times 1. But what is anything times 1? The anything, right? Yeah, 3. So this is actually just 3x to the negative 3. Now I would be done, but there's one more rule we learned about last class. What is it?
You can't have negative numbers.
We can't have negative exponents. No go. We don't like this. How did we get rid of the negative exponent? We took the entire thing it's attached to. Is it attached to the 3?
No.
It's only attached to the x, and we're going to move that to the opposite side of a fraction bar. So it's going to go down here. And now it's positive. A happy little exponent. But that 3 is going to stay up there because I didn't move it at all. So this is 3 divided by x to the 3rd. That was 2 rules combined together at the same time. Which leads us into what we're going to be doing today. Today we're going to look at problems that combine more than one rule at a time and help you learn how to simplify those down. Are you ready?
Yes.
All right, great. Let's flip it over.
Can you go back?
Yeah, I'll zoom out for a second. That's a good point. So our first complicated rule today is an advanced version of the power of a power rule. Remember, this is the rule that we already saw. This is the rule that is the PM. It's going to be parentheses, and so what do we do with those exponents? What did we do?
Add them all together.
No. If we have powers raised to powers, this is the P part, what do we do with those powers? Multiply. That's what the rule says. But when it gets advanced, if you look at this problem right here, I'm going to zoom in pretty close to it. We've got a lot of things inside that parentheses, right? But do you see how there's still a power on the very outside?
Yeah.
This is the advanced version of the power of a power rule. I want you to watch what I'm doing and then tell me what I'm doing. Everything in there gets multiplied.
It doesn't matter if it's
This is
over now.
especially when it looks like distribution. It doesn't matter that they're different letters because all of those letters are inside the same parentheses with the same power on the outside. So what happens here, and this is where students get mistaken on this. I am not multiplying 3 times the number itself. I'm multiplying 3 times its exponent. What is the current exponent for this number 2 right here, this big number 2? What's the exponent? It's invisible?
The exponent, the little number.
Not the x. What is the x's exponent? What's the 2's exponent? 1. Okay, that's what I'm multiplying by 3. What is the y's exponent right now? 1. That's what I'm multiplying by 3. And this is where students get mistaken. This is what I'm multiplying it by, is that 1. So my next step in this problem, these ones you have to show work for, would be 2 to the 3rd power, x to the 6th power, y to the 3rd power, and z to the 21 power. Whoa, let's just make sure we understood how that happened. The only thing that's left to do after this is actually multiply out the number. Because I can't actually multiply x to the 6, y to the 3rd, z to the 21, but I can multiply out 2 to the 3rd. Don't say 6. What is 2 to the 3rd? How many times am I multiplying 2? 2 times 2 times 2, which would be 8. So my final answer here is 8x to the 6th, y to the 3rd, z to the 21.
So like the big numbers can't have exponents at the end?
Correct. In simplified form, we're going to multiply them out. And if you look at this example, they're going to show you why this happened. The exponent of 3 means that that parentheses is happening 3 times. You have this parentheses 1, 2, 3 times, which means you have 1, 2, 3 2's. 2 times 2 times 2, that's 8. You have 3 x squareds. 2 plus 2 plus 2 is 6. You have 3 y's, that's 3. And you have 3 y to the or z to the 7th, sorry, which is 7 plus 7 plus 7, that's 21. So we don't have to expand it every time. We totally can just use this, I'm using air quotes, distribution of exponents to exponents to solve this problem. You just have to make sure you actually multiply it to an exponent and not the big number. That's like the number 1 mistake. Okay. It says there in bold kind of what I was emphasizing here. Your biggest mistake will come whenever the exponent is 1. So write the 1 for every exponent that you see. Let's do this first example together. First things first, let's write in the 1's. What is the current exponent for 3? 1. What is the current exponent for x? And what's the current exponent for y? 3. But we're going to take that entire parentheses and raise it to what power? The 4th, which means we're going to do some stuff like this. It looks like distribution. It is not technically distribution, but it looks like it. So that means my next step in this problem would be 3 to what power?
4.
X to what power?
4.
And y to what power? 3 times 4? 12. Now the only thing that's left to do to simplify this is actually multiply out again the regular looking number. Because I can throw that in a calculator and a calculator is going to tell me what 3 to the 4th power is. It's 3 times 3 times 3 times 3. Which is 81. This is going to be 81 x to the 4th, y to the 12th. Yes, question.
You'll multiply by 4?
Multiply what by 4? Are you, oh, the 3 to the 81, is that what you're asking about? Remember, exponents tell me how many times I'm multiplying that number. 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. It is not 12 because it's not 3 times 4. It is 3 to the 4th. And 100% guarantee the test writers and us, because we wrote some of your tests for this unit, will put 12 as the answer. 12 x to the 4th, y to the 12th. because we want to make sure that you know that this is power raised to power. You have a test next class over all of this. We will review. It's fine. All right, those were really good questions. Thank you. Let's try example 2. First things first, since I noticed that this is power raised to power, I'm going to write in all the ones, all of the missing exponents. What's the current exponent of 2? What's the current exponent of x? Current exponent of y? 2. And current exponent of z? 3. Now I can start doing power to a power, and this is where it looks like distribution. Ooh, that was the ugly arrow, but that's fine. So my next step of this problem is going to be 2 to what power? 4. X to what power? Y to what power? And z to what power? 12. Now I'd be done, but I need to multiply out that first number. Why do I only multiply out the first number and not all the letters? Because the first number is better. The first number is a number. I can multiply numbers to get a number back. I can't multiply letters to get a number, so I only do this part for the numbers. What is 2 times 2 times 2 times 2? 2 times 2 times 2 times 2. This is 4. 8. What's 8 times? 16. Guys, if that's where you're getting stuck, do not let arithmetic be the reason why you miss an algebra question. You got a whole calculator in front of you, in your hands, in your computer, on your desk. You have calculators. I want you to try it in your brain because we need to get better at mental math, but don't let arithmetic be the reason you miss this. Yes, sir. All right, let's see this geometry question. It says, a circle has a radius of 7x squared y to the 9th centimeters. The area of the circle can be found using area equal to pi r squared. What is the area of the circle in square centimeters? First things first, let's draw a picture. What's a radius? So like if I drew a middle point, it would just be like that, right? That's a radius. All right, let me label my radius, 7x squared y to the 9th. I want to know the area of this circle. It gave me the area formula. What was that area formula? Area equals, read the question again. Pi r squared, or pi r to the 2nd power. Well, don't I have a measurement for radius? Isn't my radius this number right here? Oh, snap. So let's just plug that in. So it would be pi times 7x squared y to the 9th squared. Because I'm just plugging it in for r. Now what kind of problem do I have?
Put it in distance.
Not necessarily. I got to take care of these exponents. What is the rule I just learned about exponents when they have powers raised to more powers? I'm going to multiply them to every exponent. Multiply, multiply, multiply. Oh, what did I forget to do? Write in my 1 exponent for 7. Very good. Definitely remember that because this is the kind of problem where you'll forget it. This means that I still have pi. Haven't changed anything about that. This is going to be 7 to the 2nd power, x to the 4th power, and y to the 18th power. What's 7 squared? 49. And the only reason I do this for 7 is because it's a straight up number. So my final answer here, we're going to leave it in terms of pi, is going to be 49 pi's, x to the 4th, y to the 18th. Ooh, look at that geometry algebra problem. We'll mash up today.
Is it actually geometry?
Geometry is anything to do with shapes, so a radius in a circle, yeah, is geometry.
That ain't that bad.
But we just did algebra in a geometry problem. What? Incredible. What are your questions about this?
Why does math exist?
Math exists so we can build structures around us and understand the world that we live in.
Let's just build dirt huts.
Let's just build dirt huts. I'm dead. Okay, so here's what we're going to do. But we can add another step onto the quotient of powers rule. The quotient of powers is the one where we were dividing. And what did we do with all the powers when we were dividing? What did we do?
Huh?
When we're dividing, we subtract them. Yes, thank you. Now, this is going to be fine, except sometimes when we do this subtracting, we're going to end up with negative numbers. So if you look at this first example here, they did the dividing. They did 45 divided by 15, that's 3. A to the negative 2 divided by a to the negative 4, which would be a squared, negative 2 minus negative 4. B to the 6 divided by b squared, b to the 6 minus 2, that's 4. And c to the negative 10 minus negative 15, which is negative 5. This is what they'd get after that first problem. But what do you notice right here?
That's a negative.
Am I allowed to have negative exponents in my final answers? No. So look, they just combined those two rules together. They said, okay, we're going to take this and we're going to move it down to the bottom. Nothing else was negative, so nothing else needed to move. And voila, they have their final answer. So we're adding an extra step. At the end of your problems, you have to clean them up. That's what I like to call the negative exponent rule. Just clean it up. We get rid of negative exponents at the very end. So let's do this first example together.
Thank you.
Yes, question? No, let me get through this. I'll be there in a second.
I have the answer, but
I know. I'll go.
do I move the C?
If it is negative, you move it.
So the
Hold on. On example 4, I'm going to separate every single one of these like letters and numbers just so I can see them as 4 separate little problems, okay? We're doing 35 divided by 7. What is 35 divided by 7? 5. Then I have a to the 4th divided by a to the 9. Remember, that's a to the 4 minus 9. What is 4 minus 9? 4 minus 9? Negative 5. So I have to make sure I'm taking positivity into account. Then I have the b's. What is b to the 3rd divided by b to the negative 1? That's going to be b to the negative 3 minus negative 1. Well, minus a minus, what has that always been? Positive. So this is negative 3 plus 1. What's negative 3 plus 1? Negative 2. So the new power of b is negative 2. And then I have c to the 12 minus negative 2, because I'm subtracting them. But minus a minus is plus. So this is 12 plus 2. What's 12 plus 2? 14.
Wait, but 12 not negative.
You're correct. So let me do that part again. I had a positive 12, and I'm going to subtract negative 2. And once I do that, minus negative 2, the minus the denominator, that's a plus. And 12 plus 2 is 14. Very good. Okay, that's the divide step. That's the quotient of powers. But I have negative exponents, and I'm not happy about it. I got to get rid of these negative exponents. How do I get rid of this one and this one?
You bring it down.
Bring them down. So I'm going to move both of these two terms down to the bottom. Do I move the 5 or the c?
No.
No. So my final answer should be 5 c to the 14th, all divided by a to the positive 5, b to the positive 2. So we did the regular rule. We did what the rule said. We divided the bases, so we subtracted the exponents, but then we just had to clean it up. Yes, sir?
Since they're under, you would put them as a positive in the final equation?
Correct. When you move them from numerator to denominator across the line, it changes sign. That's why we move them, because we want them to be a different sign. We want them to be positive. Yes? Let's do one more together. Your practice is going to be on your Desmos. Okay, yikes, we got a lot going on here. Let's just quickly, I'm just going to separate them into the different letters and numbers so that I can better look at what I'm dealing with here. Okay, phew, that looks a lot easier. 12 divided by 8. It's not going to come out evenly, but what is 12 divided by 8 as a fraction?
3 over 4.
3 over 4. Okay, cool. Look, I already have a fraction bar in my problem.
I got 3 over
No,
2.
3 over 2.
Oh, my bad. I was just listening to you guys. 3 over 2. Thank you. Brain's not on.
Okay, I did that first.
Now I'm going to go letter by letter. X to the negative 5 divided by x to the negative 2 is going to be x to the negative 5 minus negative 2. But minus a minus is plus. So what's 5 plus, negative 5 plus 2? Negative 3. Okay, I'm going to leave it right there for right now because I'm showing my work. Then I have y to the, what power?
6.
Oh, that's in the bottom. What's on top?
1.
1. So I have y to the 1 divided by y to the 6. It's going to be 1 minus 6. What is 1 minus 6?
No. Wait, what?
It's not 5.
Wait, what?
It's negative 5. 1 minus 6, so the negative number is bigger. And then I have my z's. I'm going to have z to the 8 divided by z third, which is 8 minus 3. What's 8 minus 3? That's 5. Okay. That's just the quotient rule. That's what we did last class. But we just have to clean up our final answers because no negative exponents. Which two pieces, which two letters need to move?
Ready.
X and Y. Those are both going to move to the opposite side of the line. And when I move it to the opposite side of the line, it's going to change to positive. So I'm going to have 3z to the 5th on top and 2x to the 3rd, y to the 5th on bottom. Just clean up the negative exponents.
There's gonna be more steps, right?
Technically more steps, yes. But you're just cleaning it up at the end. Putting a little package bow on it. Let's do another geometry problem. Are you ready? Yeah. Okay.
Oh, there was one?
The area of this rectangle is 72 x to the 9th, y to the 5th. Okay, I'm going to label that already. So this is the area, 72 x to the 9th, y to the 5th, square inches.
Alphabet?
If the length of the rectangle
Yes.
is 6x to the 3rd, y, okay, so here's the length, 6x to the 3rd, y. What is the expression for the width
Put the whole alphabet in there.
of the rectangle?
Wait, so why do you have A, B, C in an equation?
Because there's 3 variables that we don't know, so we're going to label them A, B, and C. We could have called them heart, star, and mushroom, but like we decided to use letters instead. Okay, here's what I know about area. What's the formula for area of a rectangle? Oh, let's think about our geometry. What's the formula for a rectangle?
Oh, go back.
Area equals,
Area equals, wait.
say it again,
Area equals pi.
length
r.
times width.
That's the radius of the circle.
Oh, yeah, you're right.
Yeah, base times height, length times width. Well, we know some of these things, but we're trying to find W. So it's called deriving the formula. If I derive this formula so that it says W equals, I'm going to divide by L on both sides so that the L's will cancel out over here and I just have W. So my new formula says the width is the area divided by the length. Don't I know both the area and the length?
Yes.
Sweet, let's use those two values and solve this equation. So my area was 72 x to the 9th, y to the 5th. And my length was 6x to the 3rd. Is that right? Yeah, y. What kind of problem is this now? It's a dividing problem, right? We know the dividing rules. The dividing rules say divide the big numbers like normal and subtract the small numbers. So I'm gonna split mine up again because I think that's helpful. What's 72 divided by 6? If you don't know, ask a calculator. 12. X to the 9th divided by x to the 3rd is going to be x to the 9 minus 3. And what's 9 minus 3?
1 minus 3.
9 minus 3. 6. And then I'm going to have y to the 5 minus what? 1. Very good. There's a 1 right there. What's 5 minus 1? 4. Is there anything I need to clean up for this problem? Why not?
No, because it's no negative.
There's no negative exponents. So, and just because I'm picky, that's going to be the final answer, but because it's a real world problem, we're going to give it a units, and this is 12x to the 6, y to the 4th square inches, or inches squared. That's extra. I love putting units on stuff. Okay, we're going to practice these quotient rule problems on your Desmo slide, so you have access to scoot over to them now. Go ahead and do the next few problems. So we're going to combine all of these rules together, just generally combining them together. Yes, these are challenging questions, but this is the type of question you're going to see on a test for me or on a test like the STAR test. More complicated, combining the exponent rules together. But what's nice is that there's an order of operations to these problems. The order of operations is Start by always looking for the 0 exponent property, because like that's the super easiest one to use, and we can just like cross out that part. Then we're going to do the power of a power rule. That's the distribution like one. And then we're either going to do the product or quotient. That's the multiplying or dividing rules. And then at the very end, we clean it up by doing the negative exponent property. So if you look at this first example here that they've typed on the screen, it's the first row. The first thing that they did is they said, oh, y to the 0 power, gone, that's 1. And then they did the product rule, so they multiplied 2 times 4 and 2 times 1, and 1/2 times 6. Well, 5 to the 1 times 2, that's 5 squared. 5 squared is 25. 4 times 2 is 8, that's where this 8 came from. 6 times 1/2, half of 6 is 3. That's where this number came from. The very last thing that we do is we add these two numbers together since we're multiplying those bases. 8 plus 3 is 11, so I get 25x to the 11th. There's no negative exponent, so there's nothing I have to clean up. In the second example, they started by looking for 0 exponents. There's no 0 exponents. So then I started using the product rule. In that denominator, you have powers raised to power, so I'm going to multiply them. 4 to the 1 times 2, is 16, because that's 4 squared. X to the 1 times to the second power is x squared. That's where the 2 came from. And y squared raised to the second power is 4. After this, I just have a quotient rule problem. 48 divided by 16 is 3. X to the 4th divided by x squared is x squared. And y to the 5th divided by y to the 4th is y to the 1st power. Again, no negative exponent, so I don't have to clean anything up at the end. This is the level of problem we're going to see more often in exponent problems. So let's do some of these together. We're going to do the first one together, and then I'll let you try some. What's the first rule that I look for?
The 0.
The 0. Is there a 0 exponent property here?
Yes.
Yeah, so I'm just going to cross it off because it becomes 1. It's like I'm multiplying by 1. I don't need it anymore. After that, I'm going to look for the product rule. Are there powers outside of powers?
Yeah.
Yeah, so I'm going to multiply those, but I'm going to make sure I draw all of my 1's in first so that I multiply the right number times the right number. If I just do that step, this is going to be 2 to the 3rd, x to the 12th, times 49 to the 1/2, and x to the 1. Yeah, all I've done is multiplied the little number to the little number. Do you agree? At this point, I'm going to go ahead and multiply out the regular numbers just because I want to get rid of these regular numbers. 2 to the 3rd power is 8. Oops. So this is going to be 8x to the 12th. And 49 to the 1/2 is 7. You can ask a calculator if you don't know that one. And there's only one rule left. I'm multiplying these two things together. So I'm going to multiply the big numbers, and I'm going to add the small numbers. 56x to the 13th power would be the simplified version of that complicated thing we started with. Let's pause for a second here because there's going to be questions. For time, we'll just do example 8 together, and then I want to let you try to practice some on your own. Yeah. You will be getting homework over this. All right, first step first. We look for 0 exponent property. Is there anything I can cross out?
No.
No, darn. Okay. Then we're going to go to the distribution looking rule. Remember, it's not distribution, but it looks like it. I've got a power raised to a power here in the denominator. So I'm going to write in all of the exponents here and start distributing. Okay, I'm just going to straight up rewrite the numerator because I didn't do anything with the 28, x to the 12th, or y to the 9th, but I did do something with the bottom. This is going to be 2 to the 2nd power, x to the 8th power, and y to the 4th power. Whoa, did everyone follow?
No.
Okay, I'll pause. I like that your brain went to subtracting is next, but can we take care of this right here?
Yes, you multiply those by 2.
What is 2 squared?
8.
2 times 2 is 4. Okay, cool. I just went ahead and expanded that, or like multiplied that out. And now we can do what Angel was thinking about doing, which is divide, which means I subtract the little numbers. 28 divided by 4, that's 7. x to the 12th divided by x to the 8th, that's x to the 12 minus 8. What's 12 minus 8? 4. So that's x to the 4th. And then we have y to the 9th divided by 9y to the 4th, which is y to the 9 minus 4. What is 9 minus 4? 5. That's it. I don't have any negative exponents, so I don't have to clean anything up. But if there were negative exponents, I'd have to move it to the denominator. So you see how these problems get more complicated? We're going to layer rules on rules on rules. But you know the rules. So you just got to use the rules.
Miss.
Hold on. I do really want you to see 11 and 12, though. So we're going to look at 11 and 12. This has been how they've asked questions on the STAR test for the last 2 years. So most likely we're going to see a question like this. It says, the expression x to the 6 times x to the negative 21 is equivalent to x to the p. What is the value of p? Okay, so mathematically, this is what it's saying. It's saying x to the 6 times x to the negative 21 is equal to x to the p. Basically, they've simplified the problem into one exponent. What would be that exponent? Remember the rule. If we are multiplying the bases together, what do we do with the exponents? Ooh, multiply. We add them. What is 6 plus negative 21?
50.
Negative 15, right? So here's my problem. This one we would clean up, right? But they're just asking me what the value of p is. Not that I need to clean it up or anything. So I would actually answer negative 15. That's the value of p. So you would type a negative and then a 1 and a 5 in the griddable. And that's okay. Whatever it is, positive or negative, it's just asking for what that value would be before you clean it up. NBD. Let's do number 12. The expression x to the 25th times x to the 3rd raised to the 4th power is equivalent to x to the n. What is the value of n? Okay, so we have x to the 25th times x to the 3rd, but that one's raised to the 4th, is equal to some value x to the n. We just want to know what n is. What are your spidey senses telling you to do first? Multiply the 3 times the 4, right? Is that what your spidey senses were telling you? I hope so, because that's what mine were saying. Okay, so then we have x to the 25 times x to the what power? 12. And x to the 25 times x to the 12th. Again, if I'm multiplying those bases, what am I doing with these exponents? Adding. What's 25 plus 12? 37. And is that positive or negative 37? So they're going to type in positive 37. That's the value of n that would match the same pattern from this problem.
Do you have to put the
You do not have to put the plus. You have to put the minus. I like filling in the box because I don't like leaving blanks. So I like putting the plus or the minus. I mean, you have to put the minus, but you don't have to put the plus. Yes? Okay, that's going to conclude our notes. I'm not going to do number 13 out loud. You have plenty to work on.